Hello and welcome back to our YouTube channel. So in this video we are going to see parametric functions. And what is a parametric function? Let me give you an example first. So if you have a function in the form of x equals to f of theta and y equals f of theta as well. That is y equals to a function of theta and x equals to a function of theta and y also equals to a function in terms of theta. Then we call this a parametric equation, and the is parameter is theta. This is the parameter. This is the parameter. Let me color us the parameter. This is the parameter. This is the parameter. This is what we call a parametric equation. Okay, so how do we find the derivative of this type of equations? You apply what we just did in our previous videos, chain rule. If you want to have introduction on chain rule, feel free to check the description to find the link. Okay, if you want to apply chain rule is saying that dy on dx is equals to dy with respect to another thing. In this case is d theta multiplied by d theta with respect to dx, in such a way that they have this diagonal relationship with theta as if it can cancel but not cancelling. So if you take the product of dy d theta, you multiply by d theta on dx, you will then get dy on dx. Isn't it simple? Okay, let us now take an example to really make the concept crystal clear to you. Okay, now to apply it, let us say if our x is equals to 4 theta and our y equals 3 theta. Okay, then let us look for our dx d theta. If you look our dx d theta, that is differentiate this x with respect to theta, our dx, the derivative of x is simply 1, but you always attach your dx on d theta, just like dy. Now our x is the function, equals the derivative of 4 theta will be 4, and the derivative of theta will just simply be 1, and the derivative of x is also 1, recall. So we'll just get dx on d theta to be 4, and our dy on d theta will also be equals to the derivative of this one will just be 3. And now what chain rule is telling us that our dy on dx will be equal to dy on d theta multiplied by d theta on dx. But are we having d theta on dx? I think we are not having. What we are having is dx on d theta. So we can go ahead and manipulate this to get d theta on dx. In other words, if I say a on b equals 8, then what is b on a? I can call this to be 8 on 1. What I will do, I will invert this. B over A will be equals to 1 over 8. When you invert this, you will invert this. Okay, so what we are going to do is simply to say that our dx on d theta, which is equals to 4, is equals to 4 on 1. And from here, we can find our d theta on dx. D theta on dx by inverting this will also be equals to the inverted part of this fraction. So will also be equals to 1 on 4. And that is what I'm seeing here. If a on b equals to 8 on 1, then b on a equals to 1 on 8. And if you apply that here nicely, you just simply get your dy on dx to be equals to dx is equals to dy d theta. Our dy d theta is 3, so that will be equals to 3 multiplied by our d theta on dx. Here it is, multiplied by our d theta on dx. And what is our d theta on dx? 1/4. So we just simply multiply this by 1 on 4, and we just simply get our dy on dx to be 3 on 4. And that's how you always do it. Thanks for liking the video, subscribe to the YouTube channel, and share to your friends. Thanks for watching and have a great day.